All right, today what we want to be able to do is use inverse variation and direct and joint variation. Okay, so let's take a look at inverse variation. Inverse variation is an equation in the form y is equal to k over x, where k is a constant. X and y are ordered pairs, and we have to remember that x can't equal 0 because we don't have a license yet to divide by 0. Now, if we look at an example of this, we could have y is equal to 4 over x. And now if we pick some values, like 1, y equals 4. If we let x equal 2, y equals 2. If I let x equal 4, y equals 1. And now if I let x equal 8, y equals 1/2. And let's do one more. Let's let x equal 1/2, and if we do that, y equals 8. So if we were going to go ahead and graph this, what we would get is a function that looks kind of like this. And it would come down. And the line y equals 0 and x equals 0 would be asymptotes. Okay. Now, let's say we had a table of data. Let's say we had some data like 3, 8, 6, 4, 12, 2. And let's throw in another one. Let's go 24, 1. Now, if we wanted to determine if this was inverse variation, remember that y is equal to k times x, where k is a constant. So x times y needs to equal k, the constant. So if I take 3 times 8, that equals 24. 6 times 4 is 24. 12 times 2 is 24. And 24 times 1 is 24. Therefore, this is inverse variation. Okay? Now, next we were going to talk about direct variation. Direct variation is nothing other that instead of having the x in the denominator, we're multiplying it by k. So it's k times x instead of k divided by x. And again, k is a constant, right? We use k because c is reserved generally for the speed of light. Now, hopefully some of you are looking at this and saying, this is a line with the y-intercept equaling 0. Okay. Now, again, if we take a look at an example of this, let's say we had y equals 2x. And I've set up a table of values, And let's go negative 2, 0, 2, and I'd get negative 4, and I'd get 0, and I'd get 4. So I would be here, and up there, and probably there, and there, and the line, you notice, goes through the origin, right? Because we don't have a y-intercept that we're adding here. It's y equals 2x. Now here, if we wanted to determine if a set of data was direct variation, and let's say we had 1, 3, 2, 6, and 3, 9. Remember that y was equal to k times x. So to determine if it's direct variation, we would take y divided by x, and that would equal a constant k. So if we take 3 over 1, that equals 3. 6 over 2, hey, that equals 3. And 9 over 3 equals 3. Therefore, this is direct variation. All right. Now, there are also other types of variation, and they're called joint variation. And what we have is something like z is equal to k times xy. And we would say that z varies directly with xy. We would also have something like z equals k, and again k is a constant, times xy over w. And here we would say something like z varies directly with x and y, or you would say jointly with x and y, and inversely with w. Now the last one we have is z is equal to kx over wy. And here we would call this, or say that z varies directly with x and inversely with w times y. Okay? Now, this concludes our lecture, but for tomorrow, be able to tell me ooh, we got all kinds of weird stuff going on. Be able to tell me what direct and inverse variation equations look like. Come with questions and we'll work problems tomorrow. Have a good night.